Good morning, everyone. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. I will share the event check-in link with the event ID in the Q&A section shortly. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. The session will run over the next 120 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Quick word on our code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and a co-founder at TechScalable. Being passionate about ever-evolving technology, he works on Azure, GCP, machine learning, and blockchain. He's also a Microsoft certified trainer. But for now, I'll hand over to Shivam to begin the session. Over to you, Shivam.
Thank you, Rashmita. I will quickly share my screen. Okay, so hello everyone, how are you? Hope you had a very nice week. And the last session which I delivered was last week itself, over the last Saturday. And if anyone is coming from that session, then we will use the same pattern which we generally takes. We will take a scenario today, and along with that scenario, we will solve the problem statement of the customer. We will solve the scenario, and we will learn some new technologies. We'll learn some new products. We'll learn some new approaches of taking that problem statement itself, and we will understand it on the whiteboard. We will understand it in the we will deploy it as well. So today's session is mostly on machine learning as such, and I will quickly open the agenda for this session, and I have it here with me. Now we will be talking about one customer, and in the initial 15 to 20 minutes of the session, we will focus on the problem statement of the customer. We will understand what are we doing, because it is very important when you work with data that you understand your data properly, and then you understand what is a problem statement, and then you basically solve that problem statement, or you work towards solving the problem statement. So we have this we'll talk about one customer in the starting. We'll understand what is the requirement of that customer. The customer will be requesting two things from us today. So we will be you will wear the hat of a data engineer, data scientist as well, both, or anyone who's interested into AI development, then that's also what we have to think in that regards today itself. So now we will be now we will be talking about the major services for the day will be here. We will use Databricks. We'll have Azure Machine Learning, AutoML, Machine Learning, Azure Storage, IoT Hub, PyTorch, Power BI. Now today's session, unlike the previous session where we focused mostly on HTAP, Cosmos DB, and so on and so forth, Synapse, today we'll be mostly focusing on the machine learning part, the standalone machine learning. What is RNN? What is LSTM? What is the future of RNN? What is the future of LSTM? What is the history of RNN, LSTM, and how do we train these deep learning models in the Azure platform? And then where do you train them? Like, do you use a Spark cluster to train it, or do you use a CPU GPU cluster to train it, which is not a Spark cluster? Or how do you do your model management? How do you interpret your model? How do you, you can say, explain your model to somebody who's not a data scientist as such in your company? So what are the Azure services which provides those type of functionalities? That's what we want to focus on. And we will be covering all these things on the way along with that, right? So I will start with the customer scenario first. We will understand that. We'll take some time into understanding it. I have one small slide deck with me as well. I will not bore you with the slide deck, but I will just want to run you through the few of the pages which I have over there. Okay. So today's customer is called as, the name of the customer is Trey Research. Now, what Trey Research customer is, the problem statement of this Trey Research customer is that they provide solutions for other manufacturing giants. The solutions involves usage of machine learning, deep learning, or any of the cloud platform to provide some innovative solution, which will help the manufacturing companies, uh, and or you can say the manufacturing companies has outsourced some part of the, you can say research or some part of the ML or analysis analytical requirement to Trey Research. So now Trey Research they basically, the solution, if I have copy pasted few of the pictures over here in my whiteboard. So we are talking about a connected car scenario. So the manufacturer of the vehicles basically have sensors over there. These sensors are streaming data to the cloud endpoint. Now when the data is being streamed, the car manufacturers have come back to the Trey Research asking for two things as such. First, they want, if there is any problem with any of the component in the car in real time, for example in the battery of the car, then we have to do a real time analysis that the battery is going to fail maybe today, maybe within next 30 days, or if it is beyond 30 days, then we are not that worried. But if it is any time below before 30 days, then we have to show the notification to the customer in the car's dashboard. So that alert should go back to the dashboard of the customer of the inside the car. That's one requirement. So basically it's a, the data is being streamed from this vehicle, and we have to basically do the analysis in the cloud and stream the alert back in case the component like battery is going to fail. That's one problem statement which we have to solve, or which we have to think about today in the session. The second problem statement which Trey Research is asking us to solve is that, for example, this company is working for some manufacturing giants whose vehicles are there, or different models of the vehicle is there on the road since many years. So they have vehicle make, the model make was in 1985. Some of the model makes were in 2010. Some of them were made in 1990. You can say 2000, 2005, 2000 to 2013, and so on and so forth. Various different year make models are there. Now, the cars which are new as such, like recent, which are, you can say, the model makes which are recent or new, are okay. They are still compliant. But the cars or the component of the cars which were made many years back, like in 1985, some vintage car is there, 1990, some vintage car is there, 1999, some vintage car model is there, and so on and so forth. So, which is still running today. Then the problem statement says that they want to find whether that car is compliant overall, and also is the various components that we have over here is compliant or not. Okay, I'll just mute everyone. Give me 1 second. Okay. So, for example, let's say I visit any authorized mechanic or authorized technician, and I swap some old part of my car with another new part which is manufactured, or I am swapping my old part of my car with another car, old car, and I'm just swapping the part over there, maybe through the authorized mechanic, or maybe through some unauthorized mechanic, or so on and so forth, anything like that. But some the components of the car is getting swapped as such. So we have to find whether the components are compliant. If it is not compliant, then the same logic back again. We have to show the alert to the customer in the dashboard of the car if the part is not compliant, right? So the way we are thinking, or the way Trey Research is requesting us to do that analysis, is by using NLP as such. Now, how NLP comes in this scenario? So the logic which we are using is that basically when you go to the mechanic or you go to the technician and that person swaps the part or maybe swaps some, you can say 2-3 parts of your car, then the manufacturing companies have their own authorized mechanics who also have an internal software where they give the comments about the part which they are putting in. So for example, if they have some spare part with them from another you can say non-running car and they put that in your car, then they have some information around that. So for example, they put comments like this component is in good condition, the component is in poor condition, the component is in fair condition, the component is made out of steel, the component is made out of you can say carbon fiber, the component is made out of maybe iron itself, or is a plastic component, and so on and so forth. So now based on the comments which the technicians have written when they were swapping that part of the car, based on that we have to understand, or we have to do natural language processing or text processing, or you can say deep learning using NLP techniques to to classify that particular comment of the technician into compliant or non-compliant. And if it comes out to be non-compliant, then we basically have to alert the customer in the dashboard. So these are the two requirements which we have. First is a the data of the real time battery data is getting streamed to the cloud endpoint. We have to do real time scoring on top of it. If there are alerts, show it. Secondly, the data which is coming from the technicians through the internal software, the text data on top of it, do NLP and classify that into compliant or non-compliant. That's the overall two section in which I have sort of broken this problem statement, or in which I have sort of broken this entire requirement. Now, in the next slide, I will show you a pretty big diagram. It will be very overwhelming, but then once we have seen the overall picture of what we have to do, we will go to the whiteboard and we will open the Azure portal and we will start deploying it and understanding it, what to do, how to do, and basically anything around that. Now, the focus will be on the machine learning part rather than the products itself. Like how can I do machine learning? What is recurrent neural network? How do I do sequence to see? Let's say how do I do sequence processing? How do I do some sort of time series processing, and so on and so forth, right? So check this. The sorry, let me go to the solution. Okay, check this out. Let me see if I can. Yeah, okay, great. Now, if you notice the diagram looks pretty big, right? But see, we have the this is the connected car right now. Azure IoT Hub is there. We have and the data stream is going from there. You see this arrow coming from here. It goes into Databricks as such, which is the Spark cluster, which is the primary focus of the day as such, right? And we are also storing that data which is coming from the IoT Hub in basically this in this object storage as well for the purpose of improving our own models which we are training. So that we are training with Azure Machine Learning Service. We will be using AutoML. We will also understand if I don't use AutoML, then how do I do the forecasting on time series data using some recurrent neural network. That's another component which we have to cover. So we can also think in terms of when to use AutoML, when not to use AutoML, or how much we can say what is AutoML altogether. Now, but AutoML is mostly auto ML, as it says, like it does everything for me. So we will be focusing, we will see it, but we'll focus more on the code part. We'll see how to do it with recurrent neural network, or how LSTM comes into picture. What's the difference between them? What is the basic components which you should be aware of? And in future, so you may be aware of that the RNNs and LSTMs are more, you can say, going back in history as such, and today we use more transformers. However, to understand they are not related, but to understand transformers better, if you understand the concept behind LSTM, or if you understand the concept behind recurrent neural networks, then that will make a very solid foundation for you. Okay. Now, so the data will not be in the correct format as usual. So we have to do the data cleaning. We will prepare the data. There are a few operations we have to perform. I will show it to you. So we'll use Databricks only to do it. Now Azure Machine Learning Workspace will be used. If you are aware of it, great. If you are not aware of it, then just hang in for a few minutes. Then we whatever model training which we are doing in the Databricks, we can also register the model and the telemetry and any matrices around that in the machine learning workspace. The machine learning workspace provides that entire life cycle of the model management, where you can train your model, you can register your model, you can containerize your model, you can have matrices around that, you can have comments around it, you can do data labeling, you can do AutoML, drag and drop, create some deep learning models, and so on and so forth. So everything can be done in Azure Machine Learning Workspace. So that is one of the central custom AI solution of Azure, which comes in your platform solutions. It will come somewhere in that. Now, after that, we the second problem statement which we have, the text analytical problem statement, is being, so we have this SQL database. For the text analytical problem statement, the data will be in the SQL database, and from this SQL database we basically will be reading the data in batch mode, and the in the data frame sorry in the Databricks we will be doing batch analytics on the machine learning model, which we anyways have to create ourselves. So we'll also do that. But the it doesn't matter if I'm doing real-time streaming or I'm doing some batch analytics. Cosmos database, which is a semi-structured database of Azure, is coming into picture, and in Cosmos database, and which is also distributed and global in nature. So what we are doing is, whenever any alert comes, we are creating one JSON document over there in Cosmos DB. One Azure function is sitting and is looking for the changes over there, is looking at the change feed, it is looking at the you can say the event, the document creation event, item creation event itself, and it will get triggered whenever any alert is written inside Cosmos DB. And then this is going to go back to IoT Hub and say, IoT Hub, send this alert back to the dashboard. IoT Hub is a bi-directional service. It is based on Apache Kafka. So it can ingest your data. It can also send your commands back to the remote devices. If you want to stop some device remotely, you want to start some device remotely, you want to take some corrective actions in the remote device, then IoT Hub works in all these scenarios. It's a bi-directional PaaS solution, platform as service solution based on Apache Kafka. So that will come into picture, right? It is also now, for example, let's say if you want to deploy, so we don't have any deployment requirement. For example, today we don't want to deploy this as a web service, but we can also do that. If your model is registered in Azure Machine Learning Workspace, you can definitely do a model deployment as well. Now that model deployment can be done to Kubernetes. By default, I add it in all the examples because Kubernetes is a very pretty popular, you can say, product today. So, or you can use any other thing as well. You can use Azure Web App also, or Azure Container Instances as well to do your model deployments. So this is the preferred solution. This is the overall solution. Now what I will do, I will go to my whiteboard, and then we will start from one side itself. Let's pick up from the left hand side. Let's understand a little more about the services, and then we will also pick up the we'll understand the data. We will understand the what preparation on the data that we have to do. Then what is the basics around machine learning service? How is the data which we are preparing over here is getting registered over there, or why should we do it, or why should we not do it, and so on and so forth. Any thoughts around that? And then what is this AutoML doing? And then how do we do some you can say if you have data which is like time series data, or if you have any text, or if you have any audio, or anything which is more sequential in nature, then how do we take care of that type of analysis with RNN? That's the focus of it. And then we'll see the other part as well, the deep learning part in the solution as well. So I'll just go to my whiteboard now, and I will use the same high level solution, but I will just go a little more, we can say, structured step by step, and we'll break it down for you whenever I see so fit to break it down as such, right? So now typically what happens in if you have joined me for the previous session also, if you have or if you know, already work with Azure, then you are aware of that in Azure we have this IoT Hub, which is a Kafka based solution. It's a PaaS solution. It's used whenever we have IoT devices. So in case you want to So, okay, now we have two IoT solutions actually, to be honest. We have IoT Hub is a PaaS solution. On top of it, we have IoT Central also. IoT Central is a software as a service solution built on top of IoT Hub. So now the backend of IoT Hub is Apache Kafka. Apache Kafka is the PubSub model, right? Now, like that. So the data is getting streamed from the sensors over here, right? From all the telemetry data is getting streamed from here, and so on and so forth. And the IoT Hub is capturing it. Now, once it acts like the broker over there. Now, in case you want to capture your data, capture in the sense you want to store it for historical purpose, you want to, and the reason you are storing it because you want to maybe train, as you understand, machine learning is a life cycle as such. So it's not the only model which, like we don't just train only one model. It's a life cycle. You get more data, you have better approaches. You retrain the model on some schedule. Maybe you do it once every 7 days, maybe 15 in every 15 days, maybe in 3 months, and so on and so forth. Depends on your requirement. So what you are doing, we can also store the raw data, which we are doing for the tray research, and the old workhorse of Azure will use the storage account to store it. You can also think about data lakes over there in case you have a requirement of data lake, but data lakes are around 10 times more expensive than storage account. So you can think it through. So data is being stored over here, but the other thought is that we are going to do some real-time analytics. So on the telemetry data, so the data which is coming from the IoT Hub will get streamed to the publisher, sorry, to the subscriber. And today's subscriber is Databricks. So this is Databricks cluster. And in the Databricks cluster, we will have a data frame, and using Spark structured streaming, we will be writing the data in this data frame. Imagine. So you see this green color box as such. So this is how I'm representing the data frame, and data is going in this data frame. And then we have the job which is running on this data frame in real time. There is a job running over there like this. This is what we are thinking of. And like this. But this job will be using one machine learning model in the job. So that particular machine learning model will be trained first. Like before I can run it as a job over there, I have to train it. Now, this is where the AML Studio comes into picture. Azure Machine Learning Studio over here. Now, this is the custom AI solution, right? AML Studio. Now, inside the AML Studio, we will be training one machine learning model, or it will be registered over there, basically, like this. It depends on where do you train it. But let's say this is the trained model which is registered there. Maybe there are multiple versions of it, version 1, 2, 3. And based on the versions, you may want to pull the latest version. So the scenario is something like this, that the latest version will be pulled from here, see, like that, by the job, and then it will be used for doing some for real-time inferencing over there. So let's start from the data, right? Let's have a look at the data first. Let me start with the data. Now I have done some deployments. Now a lot of the I have trained few models over here. Now these machine learning models basically will take some of them are taking 2-3 minutes to train. Some of them are taking 15 minutes to train. Some of them are took even 20 minutes to train, and so on and so forth. So what I have done, I have already kept one copy of them trained, but we will understand how to do it. And once we understand, we'll run the command again. It really sort of doesn't matter. It's already sort of ready for you. So, but let's go step by step. Let's go a little more in depth. So I have this resource group over here called as Machine Learning RG, and I have done some deployments over here. See, I have this ACR with me. It's a container registry. Here, Docker containers, Docker images are there. And inside the Docker image, I have the machine learning model as such. We'll put that in the whiteboard as well. Now I have this machine learning workspace, one storage account, one key vault as well. Now, apart from this, Databricks is also supposed to be there. So this is Databricks over here. So when you open the Databricks, this is my Databricks. And what I have done is I basically have created one compute cluster. I went over here, I clicked on it, and I basically will start it now, but I have already made it before. So it is having that 7.3 long-term support Databricks runtime over there. Go for LTS versions. It's not this 7.3 is not the recent one, but it's one of the long-term support version. Now I have minimum one node, maximum two nodes. So this red cluster which I see, which you see on this whiteboard, is basically that cluster which is coming up now because it got auto terminated, which is another feature of Databricks to do the cost saving. If there is an auto termination in the service itself, then the customer doesn't have to write that auto termination script or doesn't have to manually do it. So it's a very good feature which is there inside it. Now, apart from that, what I have clicked on the workspace and I have just imported few of my notebooks which I need, and all the entire content is available on GitHub. I will share the GitHub link with you. So whatever I'm doing today, you can also do it. Now I'm just going for my first data preparation one, and let's have a look at the data, right? So let's just look at the data first. Okay, now the data which we are getting from the battery telemetry data which we are getting is having these attributes over there. These fields are there, these columns are there. Now the one of the some little background about it. You see this the battery life cycles as such. Now life cycle of a battery, for example, means like when you charge a battery completely and the battery completely discharge. That's like one cycle. So the manufacturers of batteries or the manufacturers who manufacture these batteries, what do? They put a rating of on that particular battery, that this battery can be the number of battery cycle which this battery will support is 200 or 2000 or 20,000 or some more or less or something like that. So there is always some sort of the manufacturer always put some rating on the battery. Now, but the practical problem is whenever you are driving your car, your battery may not be totally you can say in the most ideal scenarios, it may not be the most ideal scenario as such, because the battery may not get fully charged and may not get fully discharged also. And secondly, if they might be more strained, temperature might be different. Maybe it's hot that day, maybe it's cold that day. Cold is bad for the batteries as such. So whatever the scenario is, it's not it may not be possible that we are getting that very neat, clean battery rating, how many, let's say the cycles of the battery as such from the telemetry data. So what we want to do is looking at what how many trips the person make per day, what's the duration of the trip, let's say how much distance is that person covering, what is the age of the battery, what is the rating of the battery put by the manufacturers. Using all these particular fields, we want to predict the daily life cycle of the battery. So we want to find that in one day, what is the percentage of the cycle which is getting consumed, or we can forecast that consumption for next 30 days. If the forecast of our consumption goes beyond the rating cycle, then we will understand that this customer will need some sort of maintenance, and we'll raise the alert and in the dashboard, and that person can go to the call center and can book the you can say they can replace the part or maybe get it fixed or so and so forth. So we have to find the daily cycles used, and we have looking at that value, we have to forecast the value for next 30 days as such. So, but the problem which we have found, okay, now before that, I have just done some simple things over here. Now, what we are connecting the Databricks with AML workspace. So if I click on my machine learning workspace, I click on the studio, this opens up over here. This is the AML workspace. Now, if I click on the home, that's how it looks like. We have notebooks, AutoML designer, dataset experiment, pipeline, model, endpoint, compute, environment, data store, label, linked services. We'll come to this in few minutes. But what we are doing is I have basically captured all the information about this. For example, my subscription ID, resource group name, machine learning, this service name, and so on and so forth. And I have connected it over here as well. So these are my values right now in this demo account. The name of the RGML workspace. And this is one file which we will be needing to train the model. Now, the data is available on this link. From that link, I am downloading the data locally for training the model. Now, that's the back end of it. Now, after that, this is where we were like 2-3 minutes back, and we were looking at the data itself. So this is what we have to find. This is our target attribute. This is what we have to forecast for after 30 days, like that. Now, if we analyze the data, what we found in the data is that the till 2000, you can say till the end of 2014, the 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 values were captured every 12 hours. But after 2015, or from starting from 2015, the values were captured once in 24 hours. Earlier it was every 12 hours, and afterwards it was in 24 hours. So this is 12 hours, this is 24 hours. So and it was some sort of decision which was made by the, maybe it was made by the you can say the technicians, or maybe by the engineers, basically, that we are gathering the data 2 times every day instead of 2 times every day. It's useful that we gather it maybe once every day. It depends, whatever the thought was, but we have data which is not really having the same frequency. We have this is 12 hours, and this data is having 24 hours frequency. So that is something we have to fix. That's one problem statement. We have to take care of that. So now, just to back that statement, this is the data which we have, let's say before 2014 as such. So this is where we have 2015 as such, where we have the 12 hours. The data is captured every 12 hours. So I have this uh, 1st January 2013 at 12, it was basically captured like that. And in that sense, now what we are doing is we can further visualize it. So now if you notice over here, the difference will be somewhere in the middle of it, somewhere from here. If you notice from here, like this. If you check these few values, so you will see that one data point was captured at 12, another point was captured after 12 hours at 00, and then the next data point was another in the 12 after 12 hours, and this is another after 12 hours. But from this point onwards, it will become after 24 hours. So you will see all the 0000 values over there, right? So if this is something which we have to fix first, and then we'll take care of the problem statement after that. Now, what do we do? And there are some other problems also. Some whenever you work with streaming data, data will get duplicated. So you may not want to take the duplicated data. You find your duplicate data, and then you take care of the duplicate data. So that's first thing which we are doing. And now the entire data which we have, first we are splitting that data. We are making two data frames out of it. One for 12 hours difference. The one data frame is having the frequency of 24 hours over there. Now, after once we have done that, so we'll start doing some aggregation. So we want to what we'll do, we will aggregate the 12-hour data, and we will convert it into, you can say, we'll aggregate it together to create the data points which are having a frequency of 24 hours. So aggregate the 12-hour frequency to get 24 hours frequency over there. That's the thought which we are going ahead with. The other way around, you can also think is, what happens if I split the other, let's say the frequency was the other data frame which we had the frequency of 24 hours. We can also split that. It will just create more data rows for us. So we have aggregated the first one to make it look like the second one. So once we have done it, we will merge both the data frames. And this is a basic, you can say, very simple, you can say, concat operation which we are doing over here. And after the concat operation, all the data will be having the same frequency. This is the data frame which looks like that. It is having some values till 2017 and so on and so forth. Some 15, 39 values are there. And when we look at the graph, now they all are equidistant as such. Or the frequency is actually is same for all the entire data point, and there is no difference in the data which was captured till the end of 2014, and from 2015 onwards there is no difference. We got them fixed. Now, okay, so this is a very simple, you can say, data cleaning operation which we have, data preparation operation which we have done over there, and also data cleaning also somewhere in the middle. But now what we want to do is, see, this data which you have cleaned, you have to store it somewhere. I can store it locally in the DBFS as well. So Databricks basically has a concept called as DBFS, Databricks file system, which is like a local file system. Now, but that may not be the correct way of doing it, because to be able to access DBFS, I need my cluster to be up. So I cannot access my DBFS data if my cluster is not up. That will become one problem for me. So one thing which we can do is, I can basically, the clean data which I have, I can write it somewhere. Maybe I can write it in another data lake over here. Maybe I can write the data in another storage account over here. Now, if you are aware of data lake in Azure, This is basically this is a replacement of HDFS like this. So in case you have a cluster in Azure which is using HDFS, that can be replaced with ADLS, and the cluster will get no idea, will have no idea that you have changed the storage layer over there. So I can store my data, the clean data, I can store that in the ADLS. Now we are going one step ahead. Now the problem will be, if what happens if I tomorrow I do another transformation on top of it, or if I gather more data, and now maybe some the data points has changed, my clean data is changed now, and after that I have the requirement of versioning. So what is the smoothest possible way to version my data, right? So to do that, we are going back to Azure Machine Learning service. We'll say AML service, help us out. Please create the versions of my data. Now in AML service, this is that AML service over here, like a big box, right? AML service has two concepts internally. There is a data store concept. So you see this, for example, this is Azure Data Lake, ADLS, and maybe a normal object storage. So I have this normal object storage over here, storage account. Now, these locations or other locations also, Postgres or SQL or Cosmos DB, whatever. So these locations where you really store your data are called as data stores. They just named it data store. They didn't came up with any other name. They just say data store. So if I just go back to machine learning service, you will see I have this data stores over here, right? So what is this data store? So one of them will be default data store. You see this one? It says default over here. This default is the one which comes up when I create the ML service by default, and the rest I can create, I can add other locations as well. What other locations are supported? Just click on this new on the top, just click on this blob storage, file share. Gen 1 is deprecated, Gen 2 is what we use, SQL, Postgres, MySQL, and other locations will also be, you can say we can read from other location, but may not be able to register as a data store. So by doing the registration, uh, what happens is that location sort of connects with the AML service like this. It's like a type of connection configuration. So now once I have done the connection uh, like this, then what will happen is it will show with a name over here. So what we are doing, we are going back to Databricks, and we are saying basically that, okay, get the default data store. Okay, let's zoom in slightly. You see this, get the default data store. So in case you are planning of giving DP100 certification or any Azure machine learning certification, or if you're just working in machine learning, these are very common things we do over there. So right now, what this particular line will do, this particular line means this particular name over here. Now what that particular name means at the back end is my storage account. So this basically is that storage account. So if I say that I want to write in that data store, data will go inside that storage account. So I don't have to work with the raw storage account. I have to work with the data store concept over there. Now, what is the exact path? The exact path will be written over here. So that is the exact name of the storage account slash some, you can say over there, and then file will be created inside that. So we'll go back to data bricks, and we will say that, okay, get the default data store, and inside that data, so you see a data store.upload file. So whatever data you have cleaned, you store it. Maybe you need it, maybe another team needs it, maybe your job is just to clean the data, prepare the data, another team is supposed to take care of the machine learning part, uh, right? Whatever the scenario is, you can version your data. So we are storing that data. If I say it like that, then what happens? The data goes inside the storage account. So if I just go back to my resource group and I just show it to you over there, let's say I click on it. I think this is the name of it. And I click on this. There's a very big name which we have to look for, this one. And the data should be uploaded over here somewhere. Yeah, this is the file. The time series 3 process.csv file, the output file, the CSV file. Now so now I have my data which is uploaded in that raw storage location, but I don't have to work with that directly. I don't have to work with those heterogeneous locations. I just work with this data store concept of AML, and at the backend it will do my data management. Now, one more thing which is very important over here is this is a very typical thing over here. You see this dataset.tabular. There are two type of data. Okay, so the previous word was data store. The new thing which we are talking about is data set. Now, just think it through. Let's say I have two files over there. See, two different files. Here I have some four different files. Now for your one of your requirement, you want to read these two files, and for another model training, you want to read this file maybe. So you have to tell the machine learning service. So or what you can do is you can create two type of data sets over here. So you'll come to AML, you will say data set, and there are two types. First is file data set, which we are not creating, but file dataset can be created. So file dataset will not actually have data over there. It is only metadata, you can say representation or metadata will be there as such. So what is the metadata right now is the file path or the container path of those two files. And then recursively you load that data whenever you require. So if you are doing some sort of image classification where you are working with 80,000 image, 90,000 image, then you can go for this approach. You can create a file dataset which will only have the metadata. uh, it will not have the data will really be in data store. But now from this point onwards, I can just call whatever name I give to it. Let's say I say this is Shivam's text analytical project one. I just have to type that name in my code, and then the mapping will be done by the platform. I don't have to do any further authentication. I don't have to worry about any further, you can say, authentication authorization if I have if everything is configured properly. And it will work in a very smooth manner with the least amount of configuration. Or in your main code, you don't have to add any connection string or any URL and so on and so forth. All those things we don't have to do from this point onwards. The second thing is, in case we want to load this data later, it's you're working with one single file over there, right? Let's say there is a CSV file as such, not multiple files. So now my arrow is going to the file itself. This is called as tabular data set. So tabular data set means that, again, this is just metadata, but whenever we work with one file, we create tabular data sets on top of it. There are some exceptions into that statement. In case you know the exceptions, just sort of you got that. Otherwise, typically what we do is, if you want to load one file in a pandas data frame, make a tabular data set. If you want to load multiple files recursively, make a file data set. That's the sort of rule of thumb, with only one exception as such. Now, this is what we are doing, the second one, the bottom one. So we are naming it as that. We just go back and we say that, okay, machine learning workspace, register my data set and call it as battery, daily battery life cycle data as such. Now, if I just show you that part, if I just go back to my AML service, so and just expand the left hand side, you see over here we have this option, data set. So this is that data which we registered. Now, if we ran that particular, uh, you can say, so if we run it again, then what will happen? It will just create a new version. So tomorrow, if I have done, let's say, two transformation, or I have done, maybe just to answer the Ranga's question, maybe I have done two type of normalization on the data. Maybe today I did min max, maybe tomorrow I did z score, or maybe day after tomorrow I did 10h. So and then I was training three models, and then I thought that, okay, after three days I realized that, okay, the day one normalization was the best one. It was working out for me. So now I have the capability of having everything versioned over here, and I can download my old data. I will be able to write comments with that data. It will help me in my data management. Once you start with machine learning, it's not only about the algorithm. You are also stuck with data management and model management also. So data management is pretty typical. So this is my cleaned data, which we have created over there. Now, the next thing which we have to do is we have to create a time series forecasting machine learning model which can predict next 30 days of the forecasted cycles of the battery. In case it is going beyond the standard value set by the manufacturer, we have to raise the alert, right? Now, there is, first we will do the easy way around. So there is a service in Azure Machine Learning itself called as AutoML. Now, so we go to AutoML. Now, AutoML is not like the you can say it's not really that you can just blindly always do it, but a lot of time you are able to do it. You will be able to just say AutoML, this is my data, take care of it. Uh, and train a time for let's say time series forecasting model on top of it, or maybe train a classifier on top of it, or maybe train a regression model on top of it. Use one algorithm or many algorithms, or you can just set those values and it will do it for you. So what okay, so what I will just do in front of you is that I will just use this which we have registered over there, and we will say AutoML train the model for us. So we just go back and we say AutoML, come over here, say new. It takes 7 minutes to run. So what I did, I ran it for you, and I will run it again, but it will take 7 minutes. So we will come back and we'll check out the old one, right? So you now it is saying I need the data set to work with. We have just cleaned the data set with Spark. Even if this was a huge data set in size, then the Spark would have taken care of that. AutoML is what library? AutoML is okay. So I think you want to ask is AutoML is using which library? This is proprietary Microsoft. They use everything in AutoML field. This is their inbuilt solution. You see this over here. They have created a very nice UI as well. But I can also import this in any other location. Uh, Something like this. So if I go to library, you can also have AutoML SDK for Databricks. Similarly, I will have AutoML SDK for my for Python as well for my laptop. And then the model training can be done in my laptop or can be done in the cloud as well. So it is available like this nice looking UI as well. Also, we can import it anywhere else and work accordingly. Now check this out. Now, basically, if I click on this, let's say I want to go ahead with it. So this is my data, which has been cleaned in the Databricks, and I can see the statistics around it and so on and so forth. And I will just, for now, I'll say next first. So let's go next. And now on top of it, experiments are there. Experiments are just like umbrellas. Whatever you do, if you are creating multiple versions of the model, if you want to store your telemetry data, you want to store your model matrices, you want to write some comments about the model matrices, then you create your own experiment, like your deep learning experiment. Maybe you have some text classification, you have image classification, and so on. For project 1, project 2, project 3 will be equal to like one experiment over there, and all the model runs will be registered underneath that. So I am just clicking on the select existing or create new. You give your name. So this is my demo experiment as such. Now, which column am I training for? So I am looking for the basically it's the cycles used, daily cycles used. So target attribute can be defined in this manner, uh, like that. Now, what else do I want to do? It is saying, how do you want to train it? Now, you will notice there are two options over here: compute cluster, compute instances. Typically, what happens, uh, see, this AutoML is just like you can say an orchestration mechanism, right? So at the behind the scenes, it needs somebody to train on. So we now inside Azure Machine Learning Service, we can create our own compute cluster, or Azure Machine Learning Service has this internal compute cluster. Now this cluster can be CPU based or GPU based. This is called as compute cluster. They just named it compute cluster as it is. So compute cluster like this. Now, what happens if I'm looking for a development environment? I am not thinking of that compute cluster, but I want to have an environment in the cloud for my development purpose. So as a data scientist using my laptop, I can connect to this development environment and I can do my configurations from that. This is the other option called as compute instance. So compute instance is just an environment for development purpose. You write your code over there. Now, typically, if I'm testing something, I can do the model training here also. If I don't want to engage that massive cluster, I can typically just test it out over there. If it works, I can do the model training in compute cluster. So right now, compute cluster will make more sense because I sort of have already tested it out, but that's the compute instance, the other one. So we are saying compute cluster. If you already have one, you can select it. If not, you make it. You just say new, fill up this form, make your compute cluster, CPU, GPU, and let's zoom out. Okay, way better. Now here I have this dedicated low priority. Dedicated machine means that these machines will be dedicated for me and they will run 24/7. I will pay the fixed amount for them. The low priority means basically if Microsoft is having extra compute available in that region, I can use this low priority to run my models overnight on a fraction of cost. The only problem will be if Microsoft needs the compute back, they will take it and my job will be queued. So my job will go in a job queue as such. So think it through before you select any of them. So if you don't have any time problem, you go with low priority. You can run your jobs overnight with on a fraction of cost. And otherwise go for dedicated instances and you run it in real time. Okay, now select your size from here and just select it and just go next after that. Now we have three families are there today as part of AutoML classification, regression, time series forecasting. It is by default telling me that Shivam, this is a time series forecasting requirement which you want me to train for. Maybe it is looking at the data and it is looking at that date, the timestamps over there, the recurring timestamps as such, and it's telling me. Otherwise, I can, if for other requirements, you can go for classification as well, and or if you want to find the exact values, regression. So the column which, okay, now which column is the column having, see, in when you have time series data, uh, we don't have like XYZ column like that. It's like we are going ahead in time. So the just like weather data, for example, tomorrow's data will be depending on today's data as such, or you can say points over there. So it is asking that which column is that time column. It has by default picked it up correctly. Otherwise, I would have, if there, any other name was there, we would have to manually give it. Now it is saying that how do I identify any, like how do I identify one data point? We have battery ID. With battery ID, you can identify one data point. Now the okay, enable deep learning, just by doing that we can do it, but we'll just leave it like that. Now for example, so how, okay, now what is the evaluation matrices which AutoML has to use? It can go for, in this example it is going for R squared, it is going for normalized RMSE as such, and normalized MAE over there. So based on your requirement, you will use it. Now, when we use the, if you tick it, or even later on also we can tick it, but typically what it does, it explains my model. They use two libraries called as SHAP and LIME at the backend. Those are open source libraries. They explain the model. They tell you what, that if your model has done some particular type of prediction, then why has it done that particular type of prediction? If it has granted somebody loan, or if it has not granted somebody loan, then what was the most dominating local feature or global feature, which because of which that particular decision was made by the machine learning model. Local feature means like out of my all the attributes, if some loan got passed, then which attribute is most important is local features, like locally important. Sort of globally, let me just rephrase that. Uh, or let me just correct myself over there. That's better to say. Local feature will be, for example, let's say there are two instances. One person got the loan, other person didn't got the loan. So now your boss comes and says, okay, why the first person got the loan? So you will look at the attributes of the first person, okay, C1 column, C2, C3, C4, and you will say, okay, local feature C3. Because of C3 column, his C3 column had the most, you can say, contribution to whether that person got the loan or not. So that is like local feature importance. Global is like overall in the entire data set, which is the most important attribute as such. So those type of explanations are pretty useful. And just by doing these tick marks, we can do that. Now, okay, blocked algorithms, why to run it? If we know that some algorithm will not work, we can totally block that. We don't have, you can say, many options because this is totally auto ML, right? So you will notice that how long do you want to run the job? In terms of the, okay, now these are exit criterias. Like you're saying that run the job for 1 hour. I am okay. My project's budget is to will get exhausted if I run the job for more than 1 hour, like that, right? So you can specify the values over there. Secondly, what is the upper limit after which you don't have to train further? So in terms of error, you may want to go in the other direction, like reduce the error. So which algorithm will try to reduce the error? So what machine learning AutoML does, it will try multiple algorithms at the back end. So there are around 30, 40 algorithms which this might be training on. And I have given some number over there. Okay, whenever your error is less than this, or if your accuracy is more than some number in case of classification, then you automatically stop. I don't want to train beyond that. Don't just keep on training it AutoML. Just you stop at that point in time. These are exit criteria. Any concurrency which you're looking for, how many iterations can run at the same time. This depends on my cluster capacity over here. Uh, if I don't have the cluster capacity and I gave a very big number, then the concurrent running algorithms will be queued, and whatever is practical will run over there. I will leave it default. I don't have any thought in that. I just want to say save, and let me see if there is something over here. Okay, I am okay with it. So yeah, this is a typical k-fold. Um, k-fold cross validation. So imagine you have it's like a day one type of machine learning thing, but if you have a data set, you're breaking your data into, in this example, into five pieces. When you are running your models, five models as such, and we do k-fold cross validation basically for two reasons. We want to find the consistency of our model. How is my model going to prefer when I change the data? Is it going to be consistent? Will it always give me some particular type of output, or the output will be in some particular range, or whether the output may vary a lot? If it varies a lot, that's pretty scary because it may vary a lot in final production as well. So to find your consistency of your model, how consistent is it when it sees new data? For that, K4 cross validation is a very good idea, and definitely you want to train for the best one. So we will leave it default. We'll say do five-fold cross validation for me. It will take more time, but it will run as like this. I'll just take some questions in the meantime, and we'll move ahead after that from AutoML. Are you going to normalize all forms of data? Not always, but there is a saying in our world that z-score normalization don't harm. Z-score normalization doesn't harm. Standardization of the data doesn't harm. Please share the reference material. I'll put that in the chat window. AutoML is what library? It is not using PyTorch at the backend. That's not very well documented what all it is using, but it is using multiple things at the backend, and we have this nice looking UI from where we work with it. On exit criteria, will I have partial results? Possible, but you will get the report of it. If I got your question correctly, Ranga, then basically you're asking that what happens if, let's say, 5 runs were going on, and then one of the run was terminated because of either underperformance or for any other reason as such. Or maybe it is possible that you may have achieved 95% accuracy, but because you gave 91 as the upper limit, you got it till that point as a partial result. It's practical. uh, or it is also practical, Ranga, that you don't give it and it keeps on running for next 24 hours, and you have to end up paying for it. So whatever number you give, it will stop on that number. It may be you may be able to achieve less error or maybe more accuracy beyond that, or you may never find it. You may stuck in local minima. Who knows? It will try its best in that time which you give. So by giving that time, we are able to control the budget also, and the time as well in scenarios like this. I hope that was what you were asking, right? Okay, so this guy is running. We'll run for next 7 minutes, and then this is how it looks like. Okay, so this is a typical. That's how it looks like, right? Now we will have all the basically models over here, and this let's say output child runs, and some runs were cancelled in middle. I can see many runs were cancelled. Only these 2 runs were finally went ahead. It is sort of like early termination. If something is not, see, if you are doing some epochs and in the few epochs, if you don't see any improvement in the accuracy, you just drop it. It will never work for you. So in the same line of thought, if this also drops it. So if I just, yeah, sorry, I just was looking for this option. I don't know if I remember it was on left or right. Okay. For example, now it is telling me all the matrices about this one. and then it will also tell me. So there were not many algorithm which was trained, only one algorithm gave me the result which I wanted. Otherwise, what here another option would have been there, like check the all model runs. I would have clicked on it. It would have shown me all the like for example, if I run the model for more than 1 hour, or if I don't give the exit criteria of the minimum error, then it may try multiple algorithms and will give me the best algorithm over here, or the best model which will work for me. Now, once you have done it, so for example, this is the model, this is the run which is giving us the best, you can say, result right now. We only have one. Now we have this option over here on the top, deployment. Now, in case you want to deploy this, you can have a direct deployment in AKS or ACI. We generally don't use it because this is more like testing. You will not always create a new Kubernetes cluster. You will already will have it in your company, and you will just use the old Kubernetes cluster to do the model deployment. But they have given the option in the UI for you to test it out maybe. ACI is always new. We You don't use the, because ACI is like one particular. So if you're aware of ACI, it's basically a service where we run Docker containers. So if I select this option, what will happen is my trained model will get containerized and will be running in that ACI. So this is this over here. So it's already running there. So you see this container instances. So I have this model over here like this, and it is deployed right now. It is running in this point in time. So I think I ran it yesterday, so it's running since yesterday over there for you guys to check it out. Now, so what we have done is we can use AutoML for our problem statements wherever they are applicable, right? We totally can use it. Now, once the AutoML has trained the model will be registered in the AML workspace. So if I ran it 2-3 times, it will give me a version. This is your artifact for your ML ops. Now, how do I do the deployment? Now, there is one service in Azure called as Azure Container Registry, ACR. So this model can be containerized over here like this. So that's the ML model version, let's say 3, right? And then dependencies are there. And then this is the one which is deployed over here. This image is deployed in Kubernetes, or this image is deployed in other solutions of Azure like this. So what is this ACR over here in Azure? It's called as Azure Container Registry. It's just a repository for your images. So it stores Docker image. And why do we need it? Because it will package all the dependencies used by the AutoML. Or if I do it manually, I will package the dependencies with the model. So when I do the deployment, I am not supposed to get any further error because of missing dependencies over there. And it will be more isolated and platform independent, and will be suitable to run in AKS. Anyways, otherwise I cannot run it. If it is not containerized, I anyways cannot run it in AKS or ACI. So that functionality is inbuilt inside AML service. So we typically use it. You may train your models in AML in this cluster, or you may say, I don't want to use it. I want to use the Spark-based solution over here. Totally fine. This can work with that as well, like this. So you do your training over there, but then you register your model in the AML workspace. You come back and you use that logic to save your data and models. Now, this is one line of thought. This is how we have trained you can say, the time series forecasting model using AutoML uh, over there. Now we will go in you can say, this is one line of thought, and now we'll go in the major topic of today, a recurrent neural network, LSTM as such, and we will see what do they do, why do we need them, what will they extra provide me, uh, or we will understand the basics around that. So if you have any questions till this point in time in this line of thought, please ask. I'll just quickly read the chat window if there is any new question over there or not. Okay. Okay, then check this. So, okay. Now, So okay, now let's start from a little like sort of step number one type of basics. So in machine learning, we have, for example, if this is AI, right? If this circle represent AI, then this circle is this is representing ML right now, and then this is representing my neural networks, ANN, and then maybe this is representing my deep learning or deep neural networks, where we have multiple layers over there. So this is what we are talking about right now, the deep neural networks over there. And we are talking about a particular type of deep neural network, which is called as recurrent neural network over here, RNN, right? And then there is another advancement on top of it called as LSTM. Now, these, to be honest, to put it correctly, these were very popular few years back, but today we have solutions which are way better than them, which we will definitely cover in any of the upcoming session. Transformers, right? So, and you might have heard about them, transformers, like that. So they are not really related, but transformers are sort of overshadowing RNN and LSTM today. So but that's you can say topic for another day. What we'll do, we'll first understand what is LSTM, what is RNN doing, and then maybe one day we'll come back to cover the transformers as well, using the knowledge which we have gathered today. Or you may afterwards read more about transformers using the basic understanding of what is LSTM and uh, RNN doing, or what were they supposed to do. Um, right now, okay. So we'll focus on RNN and LSTM as such. Now check this out. Now, the primary purpose of RNN or LSTM will be to these are the ones who have there was a point in time when they have dominated the world of sequence data analysis. If you are working on any sequences, uh, you would have ended up working on RNN or LSTM few years back as such. So and LSTM is there since 1995. I don't remember the date for when RNN was out, but LSTM was there. I think it was first released in 1995, like that. So like this. So they have been there since a long time now. Now they work on uh, sequential data as such. Now, what do I mean by sequential data? Basically any data which is, for example, if you talk about any so right now I'm speaking in a flow as such. Whatever I speak, whatever I say a few minutes back will be required for you to understand what I'm speaking in this point in time. This is sequential. Basically one word, let's say my first word is depending, or my second word is depending on the first word, or the context is very important over there. Like let's say first word, it is having some relationship of depending or dependency on the second word, and that second word is basically leading to the third one, and so on and so forth. And overall these statements may or may not be making sense, but typically they will have some context around that. This is sequential. Now, for example, if anyone asks you tomorrow morning stock price, that will definitely depend on today's market performance. If you have to find tomorrow's morning weather forecast, it will definitely have some sort of relationship with today's data as well. Whenever you are speaking, your audio files, your speech, like I cannot just take a point in. So if someone is speaking, I cannot understand what they are doing. I may be able to understand what word they may have spoken in that point in time, but to understand what they're saying, I have to take a patch of it. I have to take, let's say, last 1 minute of data, or I have to take one last minute, 1 minute of speech over there to be able to understand what this person is talking about. So this is a data which is moving in time, right over here. So there is a data which is moving in time as such. So like that. Aren't RNNs the building block of transformer? Answer will be no, not really. RNNs are not the building block of transformer. Transformers are totally, you can say, they are their own different things. But logically or conceptually, RNN is a building block which led to transformers today. So answer will be yes and no, right? Okay, so let's first check this. So I am dealing with data which needs context, which is I cannot have a snapshot in the point in time. I need to have maybe slices of the data of last 1 minute to be able to understand somebody's speech.
Now there are two things. We have this RNN, recurrent neural network. The other one is LSTM over there. Or let me put one more. So fully connected layers are there. Fully connected RNN layers are there. And then we'll see what is LSTM doing. And I'll make a diagram out of it. Don't worry, just hang in with me. Now, what happens is this RNN, it it does sort of state management. So state management is there, right? Fully connected layers. What is a fully connected layer? It will be looking something like this. So imagine you have some neural networks, some neurons are there, and this is how it is connected. See, like this. This is a fully connected layer, like that. It is connected to all the other outputs, dense layers like that, right? This one. So now fully connected layers which we have, they see, now if you want to understand the context, you need to remember it. You need to have a memory type of concept over there. Fully connected layers are maybe good, but they don't have any memory management capabilities, or they don't have that capability to store some information or context if the statement is there, or if we are working on some speech data which is there in recurrent neural network. We will have a memory component. Recurrent neural network will be able to remember some information from the previous input for the current input as well, right? Now this, so we'll see what is RNN, but if I add what this guy doesn't do, it has a memory concept. But if the statements are very long, right? If you have a very long statement, then this RNN will not be able to maintain the context over there. So what this doesn't do is it will not be able to hold the context over there. So the advancement on top of these RNNs will be LSTM as such, which will hold the context as well. So first we will see what is RNN, what is RNN, and then we'll go into LSTM, long short-term memory networks, which will also be having memory concept and will hold the context in a long statement or a long sequence of value. Okay, so let me say basics of recurrent neural network first, right over here, this one. Now, let's say you have this audio. Maybe you have Siri, Alexa, or something, and this is the audio as such, right? Now, if I slice this audio, so on a very high level, this is what it means. If this is my data, right, of last 1 minute or whatever time is there, I'm slicing my data. See, the audio or whatever I had, it's getting sliced. And then there is one RNN network over here. See, and then slice by slice, I'm putting that data in the RNN over here. See, slice by slice like this. Input is going over there as such. Now, but so what, and I will just say new information. I'll say information new over here is going inside the RNN to train. Now, and there is another arrow which is going something like this, right? This is the last information over there, like that. So I just want to compress this particular, and then based on this, it is giving me some outputs over here. Slices of data is there, new information, some old information is there, and then we are getting outputs. I will just compress that particular diagram into this diagram. So typically what is happening is input is coming. This is input. Then we have the RNN unit is there, let's say this one, and then output is going over there. Let's make another circle. This very typical RNN diagram is like that. And then from that particular previous input, we are getting another input into in this point in time. So this is that last, you can say last input information over here. And then, and we will just simply call it hidden state, right? Let's just call it hidden state. So this is the hidden state like this. And then, for example, I have to loop it many times. My sentence is having so many words and so on and so forth. So this particular concept will be looped many times. So I'm going to loop it, right? And I have to specify how many times do I loop it. How many times do I loop it? So this way of working is basically what that RNN will do. Just to reiterate what I just covered over there is, and let me see if there is any, uh, okay, no NES is quantum at the same state. There can be more states also, right? Maybe also. Okay, so now basically this is that RNN unit will look like that. Now, if I just make the same logic one more time, then what we are doing is, for example, if I have a big statement, let's say this is where I have a lot of data with me. This is where I have a lot of statements with me, right? A lot of documents are there, a lot of tweets are there, a lot of maybe technicians comments are there. This is all of that. Now, based on my data, what I will do, I will find the unique, you can say words out of it, and basically I will make a dictionary. So dictionary, or sorry, let's put a vocabulary first. So this is a vocabulary. We'll create one vocabulary. So for example, let's say you may have a vocabulary, I may have a vocabulary. If you deal with, let's say, food delivery application, they will have a different vocabulary. If you deal with any stock chat support system, they will have a different vocabulary, or the words which will be used in that particular vocabulary. So now, today, your customer is typing some statement, right? Some statement is there, and multiple words are there. So what do? We give these words. So typically on a high level, what happens? The words are sent to the dictionary as such. On this vocabulary, we make a dictionary like this. So word will be sent to the dictionary. Dictionary will tell the index value of that. So here index value will come out, and then this index value will go into the embedding layer. We cannot work with words itself. You have to embed it. You have to encode it. So there is one embedding layer. Just hang in with me. We'll combine all these logics together into one solution, right? And that's going to be very simple. Just hang in for 5 more minutes. So this is one embedding layer. Now in this embedding layer, basically what this embedding layer is doing, it is learning some context on the word in terms in respect to the vocabulary. So this is like representing the word in some vector format. So output will be like a vector, but that vector will not be just like a number. It will have some relationship over there with the other words inside the vocabulary. So for example, what? For example, if there is a word called as king, right? One vector representing king. If I subtract that vector with another vector representing men, and I add the vector which is representing women, the output vector will be queen, right? Or it will be near queen, like that. So this type of context will be learned by the embedding layers on the data, which will help the RNNs to become better. So now I will just make one small diagram, but we will need that in the second step. So please have a look at this. So typically in RNN, what happens? You will have input. Notice this. They will be input as such. We'll have the hidden state, the previous input. So some hidden state is there, like that. These two will be concatenated, or some sort of operation will happen on top of it, and we are combining it. So you combine this. Now, like that, combined. And then we are passing this information through a fully connected layer over there. This is FC and fully collected. And then you have some activation function on top of it. So for example, like softmax, right? Like this, and then you are getting one output. So let's say this is my output. Then in the second part, what happens? There is another fully connected layer over here, like this. And this, whatever output comes over here, whatever hidden output comes over here, or whatever output comes over here, is the same input for the next word. So this is a flow diagram of what RNN does. What it does is basically we are slicing the data, we are passing it into the recurrent neural network, and that recurrent neural network, whenever you give, so if I have a statement, quick brown fox, so the quick is the input, or when the brown will be the input, the hidden state when the quick was the input, like last time, will also be there for the calculation purpose and will be considered by the RNN. Now, if I just keep this in mind, right? RNN can work with sequential data because it is able to carry forward some information from the previous input for the next input's calculation. Now, the problem with RNN is that RNN don't work when the sequences are very long. They are unable to remember, or they are unable to have a memory type of solution. So what people did in 1995, they further modified it, they further updated that, or RNN became the building block of LSTM over there. So what LSTM does, see in the code, it will look super simple, right? But what LSTM does, so we call this long short-term memory. What it does is a very simple operation. I will need one picture. Let me see if I can drop one picture from any of the search engine. Okay, don't worry, we'll understand this. But this is what LSTM is doing based on the same recurring, you can say, logic which we were thinking of. Now, I will just break this for you and we'll try to put some basics into place over there. So, no, okay, let me paste it one more time. I will just write on this diagram. So I just want to keep it in case we have to look at it before I run you through the code. Okay, so yeah, and let's zoom in. It's not that zoomed in, right? This is one unit. You can say this is how LSTM networks will look like. Don't worry about it. See, notice this. Uh, uh, right. So you see this, the bottom part, like this part over here. This is where that RNN recurrence is going on. This is like RNN part. Apart from this, something is going on the top. You see this, we are doing some point-wise multiplication. Point-wise addition is going on. Tan function is there, sigmoid is there. Tan again, sigmoid, and some multiplication here, multiplication there, right? Like this. So what LSTM does, or what was added in LSTM is, you see the top line which I'm making over here. This top purple line over here, which I just completed. This is storing cell state, or I can say long-term memory, long-term memory. So memory like that, right? This is the long-term memory. So if I tell you a very long statement, see whatever you have learned in your environments, in your let's say production environments last year, you will have some memory of it. It will not totally be wiped off. You will have some long-term memory. If you read about some particular people, some particular book, and later on in a conversation, if that same topic is brought up, you will be able to recall from that previous memory some information. But remember that whenever you have it's not like whenever you, so let's say I tell you, so you read one you read one entire machine learning book. Now I asked you a particular question that, okay, maybe what is AutoML, or maybe what is RNN, and you recited the entire book for me. That is not correct. I'm giving you some input in this point in time. So this is the input. So look, so from the long-term memory which you have, you should answer my question based on some relevant information rather than just reciting everything which you have learned in the past 1 year, or in the entire, when you read the entire curriculum and so on and so forth. So that is important. We have to do this. We don't want to just take all the long-term memory which we are storing and just dump it whenever any input is coming over there. That is not required. We don't want to do that. It will not even make sense. It doesn't even make sense if I just ask you one question and you just recite everything you know, right? Secondly, what I also want is that you should have some information from the previous input. Like if I tell you a statement, then you should complete my statement. So you should be able to get some, you can say, filtered information from the long-term memory as well. Now, on the bottom, this is where we have those slices. You see this, these are all inputs in the point in time. So quick, brown, fox. So for example, this might be quick, this might be brown, this might be fox. So over a period of time, we are giving some inputs inside the LSTM layer. Now, the second thing is also important. See, imagine if you have learned some wrong concept, or if there is something which is not relevant, then why will you remember it? So there should be a mechanism in LSTM or in your line of thought as well, that if I learn something which is not relevant, or if in the day, if five things are happening which are not relevant, one of it is more relevant, then I should just focus on one and I should avoid the four, or I should remember the four less, or I should have less weight to it or less concept. So some forgetting concept should be there. So if I just open one notepad and sort of write it down, so I need to have a memory. That's one thing. We need memory. We want long-term memory. Let's say long-term memory. Second thing which we require is we want a forget concept. Like if the information is not relevant, then forget it or reduce the weight of it. Don't remember it that much. Forget it. Right. Next thing is, obviously, if you forget something, you should have input concept also. Like input means like what should you add into your long-term memory? What should you add into the long-term memory? So that concept should also be there. And one more information should be there is sort of yeah. Let's start with this. So now the long-term memory concept is represented by that purple line which I have in the point in time. Right now, notice this. So let's remove it and let's make this one little bigger. It got stuck with it. Let's take this one then. Now, if you notice on the bottom part, just like in RNN, what was happening, we were getting the input, current input, and the hidden state. So if I make a circle on top of it, see, you see this part, you see this part. So now, so this is a neural network which is using sigmoid function over there. So what sigmoid function will do, your output will be between 0 and 1. So if you are giving any current input, right, and this is the old hidden state, which is coming from the previous input. Now, if the so the purpose of the sigmoid neural network or the neural network over there will be, or this is what we call as a forget gate. Forget gate. So what it does, because sigmoid gives you information which is squished between 0 and 1. So if something is not relevant, if the based on the current input, if the value is not relevant for you to store, the sigmoid function will give the output which is towards 0, and in your long-term memory you will forget, or you will have a reduced weight, or you will not carry the information further. So your information will be towards 0. If it is relevant information, then the sigmoid function output will be towards 1, and then that information will not be forgotten as such, or you can say will continue to hold the weight over there. So there is a forget gate concept. So if something is not relevant, forget it or reduce the weight of it on a long-term manner. How are we doing it? With sigmoid. Similarly, so we have this forget gate concept over here. Secondly, we also have the input gate concept. Now, if you notice over here, now what will happen if I multiply something in the previous example? If I multiply something with a value which is with a vector value which is very towards 0, then whatever is over here will also becomes less in weight. Now, versus in the bottom scenario, now you are saying that Shivam, okay, forget gate concept done. What about the input gate concept? How do I add information into my long-term memory? So in the LSTM, that concept was added basically over here. This is that concept over here. This is your input gate. Now in the input gate, if you notice, we have two things. There is a forget gate over here. See, internally, this is sigmoid over here. Literally, it's doing exactly what the left hand side is doing. This is right. So the output is between 0 and 1. So if something is not relevant, forget it, right? And what is this tanh doing? Tanh will have your outputs between -1 and 1. So it will add some positive context or some negative context. For example, if you tell me something which is out of context, I will say, oh, this is very negative, like totally out of this context. I want my neural network to remember then that in this scenario, this is not possible or is very unlikely. So magnitude can be associated, negative magnitude can be associated, or that tanh is doing a filtering right now. In simple words, this is doing a filtering right now for me on the information. So I will be able to add some positive magnitude or some negative magnitude to the current input and the hidden state coming from the previous one. Now, But see, even so, what it is doing is, even if I filter it out, see, you also have to only add the information which is more relevant. Like this is filtering it out, but maybe it is not that relevant, right? So what this sigmoid will do, it will squish the data between 0 and 1. So if it is not relevant, 0 or towards 0. If it is relevant, then towards 1. So when we do a point-wise multiplication, it will have the same effect on the weight. Something is relevant, then definitely it will have a bigger weight, and then we are doing a point-wise addition over there in the long-term memory. So this is the input gate, which is uh, doing a memory net, you can say, will remember new information for you and will add it to the long-term memory. So add to long-term memory like this. Input get concept is there. Now the third third concept which comes over here is called as the output get concept, or let me drop it again. So if you just check out the rest of the LSTM, right, you notice this part. Now, what do we have? We have this, we have the current input and the hidden state coming from the previous one, and this the sigmoid function over here. So the if I just put it through, if I and make a circle on top of it, you see this part over here. Let me remove that. Now, see, this is so important. This is the most important thing, maybe. As such. Now, if you know something, don't just recite everything. Use it for the current context, or take out the information from your long-term memory and answer my current question. Don't answer and don't just dump the entire memory on top of me. So what we have done, the information, the recent memory which has been added, you see this arrow, that is going through the filtering. So using the tan h over here, we are again squishing the values between -1 and 1. And we are, in a sense, you are filtering your long-term memory and only getting what is relevant for the current input over there, and a combination of hidden state, previous one. So now the current input and the previous input, that is going into the sigmoid function. If it is important, we'll have it, but it will get pointwise multiplied with the filtered long-term memory, and that will become the next cell's input. This circle which I have over here, where we are doing filtering, so you don't dump the entire memory in the current context, but you answer something which is which is relevant, is called as output gate. This part is output gate over here. So just to quickly cover this again, there were three types of gates over there. See, what we did, we had forget gate. If something is not relevant, please remove it or reduce the importance or weight of it from your long-term memory. That is being done by the forget gate, right? By the sigmoid. Second thing which we have over here is the input gate. If something is relevant, right, for the current point of view, right, and then you remember it for long term. The third one is, but still, if you remember it for the long term, don't just dump the entire memory state into this point in time. So we are doing that with a 10H filter over there, which is like a sieve, or you can say it's filtering my long-term memory for me. This addition on top of the RNN concept is LSTM. Now, what they do, they will remember, they will start handling those long sequences for me. They will have the memory for over there. They will have the input, the forget concept. They will have the uh, adding something to the memory concept. And they will be able to use that information while doing some classification, while maybe doing some sort of language conversion, or so on and so forth, as such, in a sense. So this is LSTM. Now, just to show you how do we work with it. I have this, if you look up in any of your favorite search browser, just look up with this name, you'll find this file, right? This is publicly available. Okay, we are creating one RNN on top of the IMDb dataset, movie dataset. So this is the same RNN which we have thought about. I'll just complete this diagram. It's not totally complete. So we actually are doing embedding also. So there is one embedding layer. Then we have the RNN concept over here. RNN concept over there. And then we have the fully connected layer over there after that. So this is embedding. Embedding is whatever input is coming. If I give something, let's say quick brown fox, it has to be embedded. I cannot pass these strings as such. It's math, right? So now we'll embed that. Then we'll have the RNN unit over there, and then we will have the fully connected layer, and then you will, based on the number of neurons, you can have something. You can say 0, 1 also, or you may have multi-class type of scenarios over there. So right now I have this binary scenario in this example. We have IMDb dataset. We are doing sentiment analysis on the IMDb dataset. Now using RNN. So whatever we have learned will be there. So there is one arrow between before this as such, which is should be like it will represent the embedding. The yellow one is RNN. This one gray one is the fully connected layer over there will be written somewhere. Okay, so you can do deep learning with PyTorch. You can do deep learning with TensorFlow. PyTorch is more Python oriented. TensorFlow is TensorFlow. So technically both can be used. And if you are already an existing Python developer, then PyTorch will be more you can say PyTorch will be more will come to you naturally like that as such. Now we have this library called as torch text. In torch text, all the data sets are there. IMDb dataset is there. We want it from there. Spacey is a tokenizer. So whenever you create the vocabulary, then for example, if I break the vocabulary, if I break a sentence from the spaces or from using some logic, then that one particular unique word or one particular character is that one token. Spacey will do it for me. So it will create the tokens for me as such. Now, Spacey will require you to tell whether you are talking in English or what language are you talking about. So you may have to download some further internal libraries for that. Now, basically what we are doing over here is we are just saying whether GPU is there or not. We have attributes. We are saying Spacey using the English language, basically pick from the data set, pick up the fields which are there. Fields are like the independent attributes. Label field is the dependent attribute in that respect. So Spacey, pick it up for me. Now the dataset which we are using is IMDb dataset. Now if you run this file, which I'll give it to you anyways, the one problem will be there. The tarring, the unzipping process takes a long time. So give it time, right? It may look only 84.1 MB in size, but basically it will be pretty. It will take some time. Now I basically have my train and test data set. It is having some 25,000 observations over there. Now if I just have a look at it, these are those particular tokens which we have. High is cartoon comedy. It ran same time 35, my satire, school, repeated, and so on and so forth. We want to find the sentiment on top of it. So whatever data we have, if I just say split in the previous scenario like this, what it does, it will do a default 70-30% split. If you want to change any split, you put a proper split ratio, and then you can specify your ratio, 80-20 or any other ratio of your choice. So that is called a split ratio argument over there. Now you randomize your data set, basically do that. Now what we are doing over here, we are creating 3 of them: train, validation, testing. So with the training, we'll train the model. With validation, we will do the hyperparameter tuning, and with the testing, we'll test the model whether it is going to work or it is working out or not. So we have broken the data into 3 pieces right now, not really 2. Now, as you already remember that you cannot just pass words like that into any algorithm, because it doesn't work in that manner. You have to encode it, or you have to embed that into some sort of vector format. A very old approach of doing encoding is one-hot vector encoding. There may be better approaches today, but this is definitely one of the oldest approach. Like this, a pretty simple one. See, I hate this movie, I hate this film. So it will give some index to it, like say 0, 1, 2, 3, and then imagine the index written over here, 0, 1, 2, 3 on the top. So what it will do, wherever the index comes, it will put 1. So it will make a sparse matrix. It will make a matrix. So if I have a vocabulary of 25,000 words, then or let's say I have this 25,000 words are there, then the metrics will be pretty big, and it will have a lot of zeros over there and very less one, but this will represent my word into that one hot vector. So the words which we are dealing with are over 100,000. So what we are doing, we are limiting our vocabulary to top 25,000 words, because if my GPU may not take it, or my CPU may not be able to handle it. So we are taking the most frequently repeated words, 25,000 out of all of them. So now we have this. So for example, if you we restricted the vocabulary to 25,000, but if you see, it's adding some two extra thing over there. Like we have these two added over here. Now, in whenever we work with the natural language processing, there will be some concepts such as padding will be there. So if I have two statements, imagine this is one statement, this is another statement over there, and this is another statement over here, right? Now to make the length of the state of the words equal in the statements, what we do, we add some pad over there. This is a padding concept. Pad token is there like this. So now the length becomes uniform. Now when the length is uniform, GPU will perform very fast on top of this. So this is very good for GPU based, you can say, processing. For CPU it really doesn't matter. So we have that pad, and maybe there is something unknown, UNK will be there. So if there is any word which will come which is not understood, then it will just be having UNK or unknown token over there. So for example, the sentence number one was, I hate this movie, and this movie is not really good, pretty expressive over there, but yeah. So there we have added one pad over there just to make them of equal length. So okay, now okay, so the zero, we are not having a, so we actually are not doing a score between 0 and 1. Like for example, some of the Azure solutions like cognitive services, what do they do? They give you a score between that. Like if it is negative, then how negative? Like somewhat negative, a lot of negative, or literally someone is abusing you, right? Or maybe when it is going in the positive direction, then also is it like somewhat people, someone is giving a good feedback? Is it little good, or is it someone is just writing praises about that? So right now we are just having 0 1. 0 is negative, 1 is positive. You can also have a range of it, but this is not that scenario. What this bucket iterator will do, it will just find these, you can say, statements of the equal size, and will just pass it inside the RNN model. We are using CPU if available, otherwise GPU if available over there. Now, whatever we have understood, the entire, so RNN, LSTM will be just few line of code, right? So typically what we are doing is one hot encoding is being passed to the embedding. Embedding will give a dense vector, like the vector which is not having a lot of zeros. It will have less number of zeros, but it will have more number of, it will have values over there, right? It will not have just zeros in the sparse matrix. So that will be the input to the RNN as such in that point in time, like quick brown fox. So that brown is this is represented by that particular dense vector right now, which is going inside RNN, and this is the hidden state concept. So what we do is we are creating, so see, so this is the typical method by which we create the any model using PyTorch, not even RNN or LSTM. Anything you do, do it like this. Any deep learning model. TensorFlow works differently. Keras in TensorFlow works differently. That will be different to this. Now, for example, we have this embedding layer. RNN is just .rnn like that. In case you want to work with LSTM, you can simply put it over here. Like this .lstm. See, this is Keras example. .lstm as such, like that. So the entire concept of that hidden state and everything, or the long-term memory forget gate, input gate, is just represented by that one particular LSTM. I think the cluster got stopped. Okay, so that's why that yellow line is coming, right? So like this, and in the current example, we are embedding layer, RNN, and then one fully connected layer with one output dimension having 0 1 value, 0 for negative, 1 for positive sentiments. Yeah. So okay, now how will the feed forward happen? So in terms of the feed forward, the text will go to embedding first. Whatever output of embedding comes will go into RNN. Whatever output of RNN goes will go into the fully connected layer over there, and then the output will come as such. Okay, the input dimension. What is the input dimension? That is the vocabulary size over there. The embedding dimension, how many dimension will be there in the embedding? How long will it be? It will have 100 dimensions. The hidden dimension is 256. Output is 0, 1. So we are saying one dimension. Output will come either 0 or 1 based on it. So this is the RNN model, which is we are putting all the inputs over there uh, as such. We can also count the number of parameters. It is training 2.5 million parameters right now. So internally, it has 2.5 million parameters. How is it the way it is? See, all of these are neural networks over here. This is not like one single operation. There is a neural network here, right? This is also a neural network like that. So because internally in each forget gate, input gate, output gate, we have neural networks. So those neural networks are learning that information. So those neural networks will have those many parameters. That's why in this simple RNN, even in this simple RNN structure, I have 2.5 million parameters to be trained or learned by the uh, RNN, right? Okay, so we are doing we are using gradient descent over there, stochastic gradient descent. Learning rate will be there, and we basically have some accuracy. And if I just I thought I trained it. I will see 1 second. Yeah, correct. So we are running for 5 epochs. Okay, right, like this. Some start time, end time is there. I run it for you. It is not giving extreme good training accuracy or validation accuracy, meaning it's not really a good network. It's pretty poor right now. But if you see that we have created a very simple RNN who's trying to learn the sentiment on the IMDb dataset, and we're running it for 5 epochs right now. Epoch is just basically like we have a batch size, we have an epoch. Batch size means imagine you have a lot of data. So you are picking some data in one point in time and you are throwing inside the RNN network. That's your batch size. And when you uh, throw the entire data, you pass the entire data out of your RNN, that's your epochs. So 5 epochs are going on right now. They will take some X amount of time for you. And then we are getting some accuracy based on top of that. So this is how you create RNN as such in this. This is how you define it in PyTorch. Now, the same thing in Keras, in TensorFlow, will look like this, right? It will have a different way of writing over there. And this is basically LSTM. So we are saying embedding. So the data which is coming from the technician of which are swapping the parts in the car right now, that data is going to the embedding first. On top of that, we are doing one sequential is like sequential model layered stacks. Now embedding layer is the first one, LSTM is the second one, and then we have a fully connected dense layer over there, which will give us a sigmoid output of 0 and 1. So whether it is compliant or non-compliant. So this LSTM is the one which is doing your is learning those long sentences and finding the compliance on top of it. Now, overall in this one, we have these many parameters are there. It's we can say giving a nice you can say the input shape, output shape over here. Now, whenever we are training these models, it may be required for you to log the matrices. There are two ways in which we can store the matrices. Like whatever I'm doing over here, I'm training in Databricks, but I want to store that information somewhere because I really need to see that information after 1 month also. I may have that requirement. So now you have two ways of doing it. Either you use MLflow or you use the default Azure Machine Learning SDK. Both are doing the same thing for you. MLflow will be more, you can say, aligned with Spark. And in case if I would have trained the model anywhere else and I want to store the information about the performance of my model in the machine learning studio, I might have used the normal machine learning SDK of Azure. So what do? We basically set the tracking URI. what is the experiment name, and where do we want to log it. So whenever the model trains over here, the information will go and will be logged underneath the experiment in that model name like this. And if I click on it, it should tell me that what was the information ran by me and so on and so forth. Um, and any if I click on it, it will tell me that MLflow was used to train it. Some I can put tags over there for my own identification. As such, what was the learning rate? What was the loss over there? What is the any other matrices as such, good or bad? Any image, any let's say I did I did a sort of maybe distribution of data. So I want to visualize that, store it, child runs, output, snapshot, explanations on top of it, fairness, monitoring, and so on and so forth. Data for data drift and all that. So the model logging happens in workspace, but you just control it from there. So you specify where do you want to write into. So like this, all these graphs are going in that one. Now, so what we are doing is using LSTM, you will be able to process your text, which are having long sentences, without losing the context by using three concepts of simple forgetting, mm, remembering, input gate, and sort of filtering the memory which you have, and then proceeding to the next input in the next point in time. So this in a nutshell is what we are doing or what we want to do for the trade research for the manufacturing companies. And in case you want to deploy this solution yourself, then I'm just putting the link in the chat window. Please note it down. Just bookmark it or something. The GitHub link is going in the chat right now, right? And you will be able to get the slide deck. Plus, you'll be able to go through the entire scenario, and you can uh, deploy it uh, as per your requirement. It will take 4 or 5 hours, but you will be able to do it. Okay, now there is a question in the chat saying how to sync sequential data when data is generated in multiple time intervals of for analytics. For example, when there are 5 sensors data is required and one transmit every 1 and every 2 seconds or every 1 minute and so on and so forth. Okay, now, okay, one thing which comes to mind by looking at that is this. Now, let's say let's take care of that in terms of Databricks or Azure Synapse Analytics. Now, I there might be more approaches. I am not denying it, right? But check this. You might be already aware of it. Uh, we were talking about something called as data lake till this point in time, ADLS. But there is a new concept called as Delta Lake. Delta Lake and then Lakehouse also, but Delta Lake is a new concept. Now, what Delta Lake does, it's an open source layer which is built on top of the data lake, which is used in Azure, Databricks, or Synapse, or you can use it anywhere you want. Now, what it does, basically here, I can create, if I have streaming requirements or batch requirements, I don't have to make a Lambda architecture. I can take my same data. My same Delta Lake tables can be used for that. So what I want to say is that I have this Delta Lake table over here. Imagine this one. This is what I'm calling as bronze table, like this. Let me pull one picture of it. Yeah, Rashmita has already shared the correct link, but just I just want one picture to answer that. And let me see if I can show you. Yes. So this is the picture from the same box, but yeah, check this. So we have three type of tables in Delta Lake as such. We call them three types. You can make as many as you want. Bronze tables, silver table, and gold tables. Bronze tables are the ones which are having the raw data. So if you, and now you can have the streaming data as well. or you can also have the same data table can be used for batch requirement. So in your scenario, you may be having three bronze tables over there. One is getting the stream from the when the frequency is of one of the sensor is having 1 second frequency, another one is having 2 second frequency, third one is having 3 second frequency. So you have three tables are here which are getting data right now, and then you can, if you want to merge it together, then in the next silver table you can do that. This silver table will be the one where we have more refined output, where we have more enriched data. These tables are the ones where uh, which are somewhat processed, and the gold tables are the ones which are, you can say, reporting ready. So by using three bronze delta lake table, that can be taken care of, or by using this concept of delta lake, which will provide me with a bronze silver table concept, I do not have to create a lambda architecture anymore, meaning different hot path and cold path. That's all. This will take care of for me. I can, at the same point in time, I can read from it, I can write into it. Asset compliance as such, if something is not totally committed, it will roll back. So this is something which you can look into to handle your problem statement as such. And before it will be some sort of event hub or IoT hub over there, and some partitions inside that where the sensors were writing into. Okay. Uh, Anyone, any other question? Think it through. Okay. Then this is what I had for the session today, and the links are there in the chat. Go through that. You can go through the Databricks basics and the other GitHub link to reproduce this entire scenario. These pictures are taken from any of your search browser. Just look up for LSTM. You'll find the same picture over there, and any other document as well. So if you have questions, feel free to ask your questions. In case you have questions after some time, I will also put the my LinkedIn profile over there in the chat. You can ask me your questions over there as well. I'll be happy to answer your questions. Are bronze and silver tables the enriched and the curated? Bronze is raw, silver is enriched, and the gold is business ready, final aggregated data. This is final aggregated, this is enriched, this is raw data, bronze table, like that. Can AutoML make custom models? Custom models. Okay. Now AutoML is having, I can do regression, classification, and time series forecasting in AutoML. I still cannot do reinforcement learning over there or any other approach which comes to mind. So there are definitely some limitation. They are really making custom models for us, but there will be some limitation because whatever they do, that's only what you can do there. Rest you have to create your solution yourself. Okay. So any technical question, any other question like that? Otherwise, we'll wind up. So over to you, Rashmita and Vivek.
Thank you, Shivam. We'll just give another 2 minutes just in case if there is any last minute questions.
Sure.
Till then, let me just share my screen. If you have any question, folks, you can just unmute and ask question to Shivam. Okay, looks like we are good, Shivam. So thank you so much for hosting the session, and thank you all for joining us today. Please feel free to do event check-in and share your feedback about today's session. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you and have a nice day.